This is just a standard graphs of standard low temperature fuel cell system. You can see fuel cell stack, compressor system, and of course radiator, and so like a radiator and cooling system, which usually in standard system based on low temperature fuel cell is much as 2 times heavier than fuel cell stack itself, the circulation loop, and etc. This is standard fuel cell system design and packaging for terrestrial application. But let's imagine if we are talking about execute flights in the sky, what you have to add? You definitely have to have additional intercooler and humidifier that also will provide you additional parasitic mass. So that is why at system level, low temperature fuel cell cannot deliver enough power to lift off the ground any air vehicles. So how about our system? Why HTPEM is a much better way in hydrogen aviation? So first of all, high temperature fuel cell, it means that you can operate in high temperature of the electrochemical reaction up to 160 degrees Celsius. So that is why you don't need to use intercooler for operate that system in the sky. At the same time, so you can operate with dry air, so you don't need to think about the circulation loop of hydrogen and humidifier. And in the end, so let's imagine that your fuel cell become as a radiator itself. So our company designed lightweight aluminum bipolar plates. At the same time, it works like a bipolar plate, and at the same time, it works like a radiator. So you don't need it at all. You can exclude liquid coolant, and from the system design, you can exclude radiator and fan. And actually, you also don't need to use a pump. So you just need to replace it with standard fan, and you can see how big your system becomes much more simpler and lighter. This is a slide is comparison apple by apple standard low temperature fuel cell system and high temperature fuel cell system. And as I said earlier, it's a simpler, lighter, and more reliable. And of course, we also can consider different types of power sources, different types of fuel cell system. So this is a packaging for and the data for 500 kilowatt system for aviation grade, aviation grade, and you can see that our system high temperature, because as I said earlier, it's much more lighter. So might be compared with standard, I would say standard APUs, which right now commonly used in 777 Boeing. So you can see that high temperature membrane fuel cells from HyPoint is easily to integrate in any air vehicles and can be replaced by and can replace any power source at aircraft. And additional advantages of air cooling and high temperature membrane fuel cells from HyPoint is the lower cost because cheaper membrane chemistry. It really can be. It's a truly climate independent fuel cell which can operate in different weather conditions, including real dry air, really hot air. And a high temperature fuel cell, because of high temperature of the chemical reaction, it's a higher tolerance to different additives in hydrogen. So I would say that you, with our fuel cell, you can use any type of hydrogen which can contain up to several percent of carbon monoxide. And the system design and properties of the electrochemical reaction from HTPEM allows you to exclude buffer battery from the system design at all. All of that really allows you to get a really cool system which can replace and provide enough and satisfy requirements for, from any from air transportation market.